This is MA 110, section 7.4, and we're skipping ahead to 7.4. And what we're going to do in 7.4 is called solving systems of equations. And we've already solved at the beginning of the semester systems of equations that were linear. But in this section, we're going to solve systems of equations that are nonlinear. So these are things that don't necessarily form lines. Sometimes you'll have one thing that is a line and something else that is not a line, but the idea is you have techniques to solve things that aren't necessarily lines. So one way to solve these is graphing. I want to bring this up because, as it turns out, sometimes with nonlinear systems, the only way to solve them with the techniques that we sort of know about is by these approximation techniques or by graphing techniques. So let's look at this equation. This is x squared plus y squared equals 25. By the way, this is a circle with the radius 5. X squared plus y squared equals r squared, so a circle with radius 25. And then there's this line, 2x minus y equals 5. So let's do it the first way by graphing. So in Desmos, I'm going to type in x squared plus y squared equals 25. And that's a circle with radius 5 at the origin. And Desmos has the ability to graph this implicitly, so I don't have to solve this for y. If I'm using my TI-84, I would actually have to solve this for y, and I'll show you how to do that in just a second. And then the other one is 2x minus y equals 5. So 2x minus 5, or minus y, equals 5. So 2x minus y equals 5. So you can see from this picture that there are two places that these lines are the same, the circle and the blue line, and those are at 4, 3 and at 0, negative 5. So the solution to this system of nonlinear equations is the one point is 4, 3, x4, y3, and the other point is x0, y negative 5. That's the two solutions to this system of nonlinear equations. Okay, so let's pretend for a second that you didn't have Desmos and you were doing this on your TI-84. So what you would have to do is solve this top equation for y, and when you did that, you would have y equals 25 minus x squared, and that is that's taking this 25 minus x squared, but then I have to take the square root of this. So the square root of, I should have typed that in first, but 25 minus x squared. And I'll delete this part out. So I have this y equals the square root of 25 minus x squared. But notice my green is only a half circle on the very top here. So the reason for that is when I take the square root, I have to consider both the positive and the negative case. So I also have to do the negative case, 25 minus x squared. So if my graphing device doesn't have the ability to do it implicitly, where I can just type in x squared plus y squared equals 25, so in your TI-84 you have a y1 and you have to fill in the rest. Don't forget when you solve that you do the positive case and the negative case. And then you'd have to do the same thing for this 2x minus y equals 5. And in that case, you'd have y equals, this part would already be there, and do 5 minus 2x, and then I have to solve for y, so I have to put a minus in front of this. And so these three would be y1, y2, and y3 in my graphing calculator, and I would get the same picture, and then I would just ask for the intercept of those two places. But since we're all doing this from home, there's no problem with you doing this using Desmos online. That would be fine. Okay, so that's one way is to solve is by doing it graphically. Another way to solve is by substitution. And I put this word sometimes here. And the reason I put the word sometimes is it is completely possible that I have a system of nonlinear equations and I cannot use algebra or some what's called analytical way to solve it. I have to use approximation techniques or graphing to solve. So that's sometimes. Now, in our book, usually the problems they give us, we can solve using substitution, but that's not always the case. So graphing will always work, but there are other techniques that we can use, and we're going to talk about a couple of those techniques. So one way to solve is by substitution. So this is the same problem as I had before. This x squared plus y squared equals 25, the circle, and 2x minus y equals 5. So what I did is I took this bottom equation, 2x minus y equals 5, and I solved that for y. So what did I do? I added y here and got 0, and I have this positive y over here. I move this negative y over to the other side by adding. And then I move this 5 over to this side by subtracting. So I solve this equation, 2x minus 5, or 2x minus y equals 5 for y, and I get 2x minus 5 equals y. Then what I'm going to do is plug this value of y, substitute that into the first equation. So y is the same as 2x minus 5. This y will go into that first equation. So I have x squared plus y, but y is 2x minus 5 equals 25. So that's what I did down here. X squared plus y squared, but y is 2x minus 5 equals 25. So I have x squared, and then I FOILed this out. And when I FOIL this out, don't forget I have a middle term, so it's 4x squared minus 20x plus 25. So when I FOIL this, I have first and outsides and insides and last. Or I can remember that I can square the first, square the second, and double the multiplication of the two in the middle. That's something we should remember from Algebra 1. But just don't forget you have this middle term. So then I have x squared and 4x squared for a total of 5x squared. And I have minus 20x, so minus 20x. And then this plus 25 and this 25 over on the other hand side. If I subtract it from both sides, I'll get 0. So now I have this new equation, 5x squared minus 20, x equals 0. And so what did I do to solve that? Well, I factored out a 5x out of the first term, and that left me with x. And I factored out a 5x out of the second term, and that left me with a minus 4. So if I multiply this back in, 5x times x is 5x squared. 5x times negative 4 is negative 20. That's equal to 0. So that means 5x is equal to 0 or x minus 4 is equal to 0. And that solving each side, I get x is equal to 0 or x is equal to 4. Those are my two cases. So if x is equal to 0, so I look at each case, if x is equal to 0, I go back to my original system of equations and I plug in 0 wherever I see x. So 0 squared plus y squared equals 25. 2 times 0 minus y equals 5. And that's what I've done down here. 0 squared plus y squared equals 25. 2 times 0 minus y equals 5. When I do all that, that simplifies to y squared equals 25. Y squared equals 25. And minus y equals 5. Minus y equals 5. And I solve this and I get, take the square root of both sides, and I get y equals plus or minus 5, and I get y equals negative 5. And I'm looking for the one that is true in both cases. Well, there's only one that's true in both cases, and that's negative 5 and negative 5. So y equals negative 5. So if x is equal to 0, then y is equal to negative 5. And we saw that graphically already, so that's one of my, my points. So my other point is if x is equal to 4. So what I do again is I go back to my original equation, and wherever I see x, I put in 4. So 4 squared plus y squared equals 25. 2 times 4 minus y equals 5, right? So I go all the way down here, and I did that. 4 squared plus y squared equals 25. 2 times 4 minus y equals 5. And when I simplify this, I get y squared equals 25 minus 16. So I took this 4 squared and moved it over to the other side. So y squared equals 25 minus 16, which is 9. Then I got 2 times 4, which is 8, minus y equals 5. So I have this minus y, and then I have 5, and I took this 8 and moved it over to the other side. So I get minus y equals 5 minus 8. So 9 minus y equals minus 3. 5 minus 8 is minus 3. So this is a negative, and this is a negative. I divided both sides by -1, and I got y equals 3. Y squared equals 9. Well, when I solve for y, I get y equals plus or minus 3. Take the square root of both sides, so I get plus or minus. So I have the case then of y equals 3 or y equals 3, so y equals 3. Okay, so when x is equal to 4, y is equal to 3, and that's the other one that we saw from the graph.